Alright, let's take a look at our lesson on writing quadratics. We're going to learn to write a quadratic equation, whether we're given roots or maybe the vertex and a point or 3 points. We're going to look at several different ways with different given information on how to write a quadratic equation. So one of the really actually pretty important, or well, I guess it's important to me because it makes my life easier. This little formula right here, if you have two roots, so basically this formula works with two roots. If you have two roots of the quadratic equation, then you can use this very cool formula to find the equation. You basically would find the sum of the roots, and you'd find the product of the roots, and you'd plug those numbers in here or substitute them in where I have the pink circles right here, and then that would give you the equation, which is actually pretty cool. But you don't have to memorize that formula. There are other ways to do it, and so we'll go through two different ways to be able to use two roots to find the equation. So first off, let's not use the equation, and let's just think about if I was told that the two roots that I have for the particular quadratic equation were 3 and -8. How could I go backwards from that? So what would that have looked like? Wouldn't x minus 3 have been the factor to go with an x equals 3? That seems reasonable. And wouldn't x plus 8 go with, the root or 0 of -8? So we could do, that's one way to do it. And so we would have, we would just FOIL that out, and we would have x squared plus 8x minus 3x is a plus 5x minus 3 times a positive 8 is -24. So that's one way to do this particular technique without having to memorize this super cool formula up here. Okay, so now let's use the super cool formula. So we know those are our roots. If we add them up, the sum of the roots would be 3 plus a -8. That would give me a -5. And then the product would be 3 times -8, which would be -24. Then we simply plug into that formula, x squared minus sum, which is -5x, plus product, which is -24, and they have it equal to 0. So cleaning that up, that'd be x squared plus 5x minus 24, in this case equals 0, or you don't have to put it equal to 0, you could put it equal to y. That's perfectly fine. And these are the same. So you can do it either way. All right. This particular equation right here is especially helpful if your roots are irrational or imaginary. They really are helpful. And when we have imaginary roots, if you recall, they come in pairs. They're conjugates of each other, so 7 minus 3i and 7 plus 3i. In fact, they could trick us, and they could just say, give us this 0 and not give us this. And then we would have to know that if one of the zeros is 7 minus 3i, then the other one has to be 7 plus 3i. That has to be the conjugate. So even if they didn't give us the second one, we would have to know what the second one was. Okay, so let's use the super cool formula first. The sum would be 7 minus 3i plus 7 plus 3i. And that would give me, 14, because the i's cancel out. Then we'd have product would be 7 minus 3i times 7 plus 3i, which would require us to FOIL. That would be 49 with the plus 21i minus 21i minus 9i squared. Of course, we see the i's go away. And we know that I squared is a -1. So this is 49 minus 9 times a minus, so plus 9 would give me, what, 58? So my formula would be, let's just fill in the blanks. So we'd have, instead of a equals 0, let's do a y equals. Y equals x squared minus 14x plus 58. So that would be how we would do it using the formula. Now let's say we wanted to, or maybe we forgot the formula, and we wanted to just do what we did over here, this technique where we set up the factors. Okay, so a factor, if you see what we did is we put the x minus in front of the 3 and the x minus a minus, in front of. So, I mean, that's how you set up a factor. We would just say x minus 7 minus 3i and x minus 7 plus 3i. And now, in order to, we'd have to multiply all that out, right? That's what we'd have to do. If we were going to use, if we forgot this formula, the formula above, we forgot it or didn't want to use it, we would have to do this. We'd have to FOIL all that out. So I'd have x times x is x squared, x times -7 is -7x, x times 3i is 3ix. Whew, gotta keep going. -7 times x is -7x. -7 times a -7 is a positive 49. -7 times a positive 3i is a -21i. Okay, 3 more. -3i times x is -3ix. -3i times a -7 is a positive 21i. -3i times -7, yeah, positive 21. Then I've got a -3i times a positive 3i is a -9i squared. Oh, goodness. Okay, so let's see, I've got the positive 3ix minus 3ix, because the i's should always go away. If they don't, we've done something wrong. -21i, positive 21i, then that I squared is going to be a -1. Okay, so let's get this all cleaned up. So I've got x squared minus 14x. I've got plus 49 minus 9 times a -1 is a positive 9. So I've got x squared minus 14x plus 58. So you can see that regardless of which way we do it, we should come up with the same answer. It's really, what is our preference? Would we like to memorize that formula, or would we like to do factors every time and then FOIL everything out? So it's really your choice. All right, let's move on to the next types. So I'll go to our second page. So here, this example, we let's see, write a quadratic in vertex form whose graph has the given vertex and passes through the given point. All right, so we don't have the factors, we can't, or the zeros, we can't proceed like we did on the previous two problems. We need a fresh start. We know the vertex, so why don't we use, and I'll write this down, something you kind of need to know. It's basically just the standard form of a quadratic in vertex form. So this is just a formula. If you know this formula, it will make your life easier. All right, so vertex, we know that that's h and that's k. So we can put that in for h and k. And we know this is an example of an x and a y in the particular quadratic. So really the only thing we need to figure out is what is A. We don't know what A is. So we're going to plug in all those values or substitute them into this standard formula, the standard vertex formula. All right, so our y is 1, our x is -1, minus h is -3, plus, and then k is 3. So now it becomes an algebra problem, just, working through and solving for A. Okay, we can do that, no problem. So let's see, we move the 3 over, gives us a -2 equals A times, let's see, -1 minus a -3. -1 plus 3 is 2. Okay, so then we would divide 2 squared is 4. So -2 over 4, or -1/2. So A is -1/2. Yay! So now we can write our equation out. Well, and luckily they want it in vertex form, but if they wanted it in standard form, we certainly know how to fix it. So minus a -3 is +3. And there's how we would do that if we had a vertex and a point. The very last one is probably, I don't know, to some is the most challenging one, because really all we have are 3 points. We just have 3 points. And so the best technique to use for this would be to write a system of equations and solve a 3x3, a 3-variable, 3 system of equations. But we are going to use a calculator to actually solve it. So our work is going to be in writing the system. And so we're going to use, instead of vertex form, we're actually going to use standard form. Y equals ax squared, again, plus bx plus c. A formula you really need to know. Okay, those are standard right there. And so this is x and y. We'll call it x1, y1, x2, y2, x3, y3. So those are going to be our different equations. Okay, so let's start with the first one, the x1, y1. So y is -3. A times -4 squared plus b times -4 plus c. So our equation is -3 equals, what would that be? 16a minus 4b plus c. Okay, so there's our first equation. So let's write our second one using the second point. So -2 equals a times 0 squared plus b times 0 plus c. So c is -2. That's our second equation. Our third one, okay, so we've got 7 equals a times 1 squared plus b times 1 plus c. So we have 7 equals a plus b plus c. There is our third. All right, so if you recall, perhaps you recall from a previous unit how we worked with matrices in our calculator. Instead of trying to solve this by hand, we're going to allow the calculator to do it. So what I'm going to do is I'm going to set up a matrix. And we'll put that in our calculator. So if you recall, I'm going to line up the A's and then the B's and then the C's and then the numbers. That's what I'm going to do. So I've got 16, a -4, a 1, and a -3. So I just took this equation and I wrote down its coefficients. Okay. So this particular equation does not have an A or a B. So the A would be 0, B would be 0, C would be 1, because that's 1C, and then my answer is -2. And then the third one would be 1117. That's the third one. All right, then what we would do is we're going to put that in our calculator, and we're going to do, if you recall, reduced row echelon form. So let's pull up our calculator. We'll just put it on top of here. So, all right, press menu. We're going to, let's see where we were. Oops. Menu. Let's get out of here. We'll just add another page when we don't know. We just add another page. Great. Let's do a calculator. Okay. So menu, we've got probability. Nope, where is it? Algebra. Oh, of course, it's under matrix. Hello, matrix. Create. We're going to create the matrix. Let's see, we've got 3 rows. So we've got 3 rows, and then, oops. We've got 3 rows, and we have 4 columns. Okay, so let's input our matrix. So we've got 16. Okay, we know you don't like that. We'll have to arrow over. 16, -4, 1, -3. Then we have 0, 0, 1, -2. Then 1, 1, 1, 7. Okay, now we're going to have to store this little guy so that we can use it. You know, we've got to use it and do the RREF, reduced row echelon form, but we need to store it. So let's store it. Let's store it as, I don't know, letter A. That seems fun. Enter. So now every time I write an A, it pulls up that matrix. Okay, so let's go into our menu. Let's go into our matrix menu, and now we're going to do reduce row echelon form. See number 5, reduce row echelon form on matrix A, which, you know, we just wrote, and hit enter. So what this has done, you see the ones down the diagonal, this has given us our answer. Basically A, because we wrote A first, then B, then C. So A is 7/4, B is 29/4, and C is -2. So now we get to write our, so we just need to show our matrix. We input our matrix, and now we're going to write our answer. That was 7/4 x squared plus 29/4 x minus 2. And I'll pull up that calculator so you can see. So we've got, see, the 7/4, 29/4, and the -2. Yay! All right.